Good day, my SS2 students, and hello to everyone out there. My name is Mr. Seun Akinmolayan. I teach physics at Sleep Angels International School. And today, I'll be taking the SS2, a topic, refraction of light. Before now, we have learned the theoretical aspects of refraction, where we defined refraction, and we consider refractive index. We talked about the critical angle, and then the total internal reflection, and so on. But today we shall concentrate on solving some problems on refractive index. So, refractive index, we have defined it as the sine of the incident angle over the sine of refracted angle. And so today we have some examples to explain further what refractive index is all about. So we have example 1. Example 1 says, a pin placed in contact with one surface of glass block of thickness 1.5 centimeters and the refractive index 1.5 is viewed along the normal to the opposite surface. By how much does the pin appear to be displaced? Let's read the question again so that we can comprehend accurately. A pin placed in contact with one surface of glass block of thickness 1.5 centimeters and refractive index 1.5 is viewed along the normal to the opposite surface. By how much does the pin appear to be displaced? Okay, so solution. We're given the thickness of the glass. We have an example of a glass here. This is a rectangular block. You can call it a rectangular glass. So the thickness is given to be 1.5 centimeters. But then when you view this from the top, it appears to have lesser thickness than the actual size. And so we are told that by how much, therefore, does a pin appear when the pin is placed in front of it? By how much does the pin appear to be displaced? So it means first we must consider the apparent depth. In the previous class, we talked about real depth and apparent depth. We said that if you are on top of a clear pond or swimming pool, the swimming pool or the pond appears to be closer to you. The depth appears to be closer to you than the real depth. And so, in terms of refractive index N, refractive index N equals real depth over apparent depth. So for this question, we need to first find the apparent depth. So we have the real depth, that's the thickness. So real depth, we have real depth equals 1.5 centimeters. We have the N, which is the refractive index. N equals 1.5. So we have to find the apparent depth. So we're not given. So using that formula, we have N equals the real depth 1.5 all over apparent depth. So if you cross multiply, N is already 1.5. So we have 1.5 over 1.5, everything over apparent depth. Okay, so if you cross multiply apparent depth equals 1.5 over 1.5, 1.5 centimeters over 1.5. The refractive index does not have a unit. There is no unit for the refractive index, so that is why it is given to be 1.5. So apparent depth from here, 1.5 over 1.5 will give you 1.0 centimeters. So you have 1 centimeter. That's the apparent depth. But that's not the question. The question says, by how much does the pin appear? So it means for it to be displaced, what now the difference between the apparent depth and the refractive index, that is the actual size, the thickness. So displacement of the pin, displacement of pin equals real depth minus apparent depth. So we have 1.5 centimeters minus 1.0 centimeter. So displacement, therefore, displacement equals 0.5 centimeter. So that's the displacement. By how much does the pin appear? So the difference between the real depth and the apparent depth, based on this calculation, is 0.5 centimeters. Okay. All right. That's about refractive index. We have another example talking about the triangular prism. In the previous class, we gave the formula that is to be used to calculate the refractive index of a triangular prism. Now, this is an example of a triangular prism. This is an example of a triangular prism. And it is equilateral. It is equilateral. I explained that in the previous class. It is equilateral because it has all the sides equal. And then for any equilateral triangle, all the angles are also equal. The sum of the angles in a triangle is 180 degrees. So divided by 3 will give you 60 degrees each. So the 3 angles of an equilateral triangle, each of them is 60 degrees. On the basis of that, we look at example 2. Example 2. A ray of light experiences a minimum deviation when passing through an equilateral triangular prism. A. Calculate the angle of minimum deviation, dn. B. Calculate the angle of incidence, I. A ray of light, I take the question once again. A ray of light experiences a minimum deviation when passing through an equilateral triangular prism. A. Calculate the angle of minimum deviation, dm. And B. Calculate the angle of incidence, I. We're given refractive index of glass is 1.5. Refractive index of glass is 1.5. Okay, I promised to show this in the previous class, that in the next class that is going to be a video, we shall see how we can apply that formula to solving triangular prism problems. Okay, so based on this question, let's take our solution. Okay, let's list out whatever we are given. We have refractive index. Refractive index n equals 1.5. Now the angle in the angle of an equilateral triangle. Equilateral triangle. A is 60 degrees. Equilateral triangle. Each of the angles is 60 degrees. So using the formula n equals sine 1/2 bracket minimum deviation plus the angle all over sine 1/2 of the angle. So there is need for us to actually understand how to apply this formula. So n has been given to be 1.5. The minimum deviation, we need to get that first. Then we have the angle of the equilateral triangle, which is 60 degrees. Okay, so using that, we have 1.5 equals sine 1/2 bracket minimum deviation plus 60 all over sine 1.5 then bracket 60. Okay, so 1.5 equals sine 1/2 bracket minimum deviation plus 60 all over half of 60 is 30 degrees. So half of 60 degrees is 30 degrees. Alright, so we have 1.5 equals sine 1/2, the minimum deviation, plus 60 all over sine 30. This 30 is from the half of 60. So half of 60 is 30. If you cross multiply, you have 1.5 times sine 30 degrees equals sine 1/2 bracket minimum deviation plus 60. And so if you punch your calculator, sine 30 degrees is 0.5. So we have 1.5 times 0.5 equals sine 1/2 bracket minimum deviation and then 60. Okay, so if you multiply 1.5 by 0.5, you're going to have 0.75. Okay, 0.75. So let's look at that. If you continue from here, we have 0.5 equals sine 1/2 bracket minimum deviation plus 60. Okay, so you can bring sine to the other side. So you have arc sine. Inverse of sine will be arc sine 0.75 equals 1/2 bracket minimum deviation plus 60. So from here, if you punch your calculator, arc sine 0.75 will give you 48.59, which is 1/2 dm plus 60. Okay, so if you also multiply, you cross multiply, because this is dm plus 60, everything is over 2. So you cross multiply, you use 2 to multiply this, so we have 48.59 times 2. Everything gives you dm plus 60. Okay, so if you multiply this, 2 times 9, 18, keep 1. 2 times 5, 10 plus 1. That's 11, so you write 1, keep 1. 2 times 8, 2 times 8, 16 plus 1, you have 7. And then 2 times 4 is 8 plus 1, that would be 9. So you have 97.18 equals dm, minimum deviation plus 60. So for A, if you make dm the subject, you bring 60 to the other side. And don't forget, as a mathematics student, whenever your term is moving across the equality sign, the sign changes. So we have therefore 97.18 minus 60 equals dm. Therefore, minimum deviation dm equals 37.18. That's the angle of minimum deviation, 37.18 degrees. Okay, that's for A. B says calculate the angle of incidence. Calculate the angle of incidence. Please, I want you to take note of this, that at minimum deviation, the angle of that equilateral triangle, that capital letter A, equals 2r, 2 times the angle of refraction. So at minimum deviation, dm, at minimum deviation, A equals 2r. So 60 degrees equals 2r. So r equals 60 over 2, and that will give you 30 degrees. Remember that your refractive index n equals sine I over sine r. Refractive index equals sine I over sine r. So we're actually asked to find the incident angle. We're to find the angle of incidence. So n, we're given n to be 1.5 equals sine I over sine 30 degrees. Since r is already 30 degrees. So if you cross multiply, you have 1.5 times sine 30 degrees equals sine I. So sine 30 degree is 0.5. So we have 0.5 equals sine I. So if you make sine I the subject, or I the subject, you find the inverse of whatever is happening here. So we have 1.5 times 0.5 will give you 0.75 equals sine I. So I, which is angle of incidence, equals arc sine 0.75. So from there, the angle of incidence therefore will give you 48.59. 48.59. So the angle of incidence, therefore, angle of incidence equals 48.59 degrees. So approximately you can say I equals 49 degrees. Angle of incidence equals 49 degrees. So like I said, where you are expected to take note is at minimum deviation, the angle of an equilateral triangle equals 2r. Alright, we go further to check some assignments that will be given to you. Okay. Alright, we have an assignment here. There are 2 questions in this assignment. You are expected to solve them and then send your answers to my phone number, my WhatsApp number, or my email. Okay, so let's look at the 2 questions. The first one, the refractive index of a medium relative to air is 1.8. Calculate the critical angle for the medium to the nearest degree. Let's take that question again. The refractive index of a medium relative to air is 1.8. Calculate the critical angle for the medium to the nearest degree. Number 2. A submarine is observed to rise from a real depth of 80 meters to 60 meters in water. Calculate the change in apparent depth. Given refractive index N for water is 1.33. A submarine is observed to rise from a real depth of 80 meters to 60 meters in water. Calculate the change in apparent depth. You're given the refractive index N for water to be 1.33. So please attempt the questions. Don't forget that the refractive index is real depth over apparent depth. So you can attempt that and then forward your answers to my WhatsApp number on 080-3479-6589 or my email princeoluwaseun91@gmail.com. princeoluwaseun91@gmail.com. Alright, we have come to the end of this video, and I want to appreciate those of you that have been sending your questions and your homework to my email or my WhatsApp number. I really appreciate you. But then please stay healthy, stay safe at home. Regards to your parents. Bye.